Welcome to Trig word problems. There is no certain process to trig word problems. It's just learning how to read the problem, draw your figure, and then use SOHCAHTOA. First thing we need to talk about, what is an angle of elevation and angle of depression. Angle of elevation is basically the angle when you look up. So if here's your eye, then the angle when you look up, you always have an angle or a line that is parallel to the ground or that represents your ground, and the angle formed there from your eye is your angle of elevation. Angle of depression is like if you're up on a hill, and here's you, and you are looking down. Again, you're going to have a line that is parallel to the ground, and then that angle formed there is your angle of depression. So we're going to start with a problem here. We have a road rises 10 feet in a horizontal distance of 200 feet. What is the angle of elevation? So if we're talking about a road rising, we're going to draw a line here, there, that represents my road. It rises 10 feet in a horizontal distance of 200 feet. So that 10 feet is representing a vertical length, a vertical distance, and a horizontal distance of 200 feet. So that means straight horizontal. So the bottom of my right triangle here is going to be the 200 feet. There's my right angle. We need what is the angle of elevation. So angle of elevation is always going to be down there at the road or down there at the ground. So what we need to do is what we did in our last assignment. We need to figure out opposite, adjacent, hypotenuse and use our SOHCAHTOA. So there's my angle. My 10 is my opposite. My 200 is my adjacent, which means I'm going to use tangent. So on this one I would have to start with tangent of theta equals 10 over 200. Remember from here, I need to start by dividing 10 and 200. So 10 divided by 200 is going to be 0.05. Since we're looking for the angle, that means we're going to have to do our second tangent. And once I do that, my theta, my angle there, is going to be 2.86 degrees. And that is my angle of elevation. Our next problem we're going to try is about a surveyor. So go ahead and read that problem. When it talks about a tower, I would assume it's going to be something like a cell phone tower. A surveyor is the person, if you've ever seen on a highway or on a road, where he has a tripod and he's looking through some kind of device on top of the tripod. And then he's looking over here at a tower. So here's my tower. He's looking through that hole up to the top of the tower. So he's 130 feet from the tower. So what I'm going to do is, from that line of sight, I'm going to draw a horizontal line straight across. There's my right angle, and this is going to be my 130 feet. The tower is 86 feet high, so that means from very top to very bottom is 86 feet. The surveyor's instrument is 4.75 feet. And we want to find the angle of elevation. So again, angle of elevation is going to be down here at the ground because you're looking up. Now our issue here is on the actual triangle, I only have one measurement, which would be a side. So I need to figure out another measurement. What I need to look at is I have two vertical measurements here. Top of the tower to the very bottom is 86 feet, and then the surveyor's instrument is 4.75 feet. So what I need to do is take 86 minus 4.75, and that gives me 81.25. So the length of this side of the triangle is 81.25. Now from there, here's my theta. I need to label my sides as opposite, adjacent, and hypotenuse. So the 81.25 is my opposite. The 130 is my adjacent. So if I look at my SOHCAHTOA, again, I'm going to be using tangent. And we do tend to use that a lot on our word problems. So we need to do tangent of theta equals 81.25 over 130, because again it's opposite over adjacent. Take your 81.25 divided by 130. That gives me tangent of theta equals 0.625. Then I need to inverse tangent. And that gives me an angle measure of 32 degrees. So this one was a little bit different because we had to find out this measurement over here that we did not know before we could use SOHCAHTOA. I want you to take a look at one more problem here. And go ahead and read that. When they mean raked stage, that means that you're going to have an angle to the stage. So the stage will be 30 feet long with a rise of 2 feet. And we want to know if it fits within that 5-degree elevation. So if we're going to have a drawing of the stage, basically down here at the bottom, the lowest part would be down by the audience. If it says the stage is 30 feet long, that means the actual stage here is 30 feet. We have a rise, which would be straight up, of 2 feet. We're not going to put that 5 degrees in as the angle. We're going to put theta there because we're going to find out how many degrees that this is. And then from there, the 5 degrees is going to tell me if yes, it fits the building suggestions or not. So from here, here's my angle. My 2 is my opposite. My 30 is my hypotenuse. We're going to use SOHCAHTOA again. So we have opposite and hypotenuse, which would tell me that would be sine. So we're going to do sine of theta equals 2 over 30 because it's opposite over hypotenuse. So again, we got to start by taking 2 divided by 30. So sine of theta is 0.0667. And then do your inverse sine. Make sure you're using the correct trig function there. And then this gives me an angle measure of 3.8 degrees. So 3.8 degrees definitely is within the 5 degree or less. So is the rake stage you're building within the range suggested? Yes, it is.